Hello everyone, my name is David Shrestha. Our group members consist of Matt Ponto, David Seekins, and Stephanie Bello, and our project here today is the dog monitoring activity system. Our system will allow for the owner of the dog to track the activity throughout the day, as well as allow the dog to go in and out of the house as it wishes. So it's going to be broken down into 4 parts. The dog monitor will have a hardware and software component, and the dog door will have a hardware and software component. So why is this necessary? Well, the Internet of Things is the next big industry to be coming out in the next decade. It's going to be what the Internet was back in the early 2000s. Our product is going to basically be one of the first to be implemented into the pet industry, which is going to be huge because this is what bridges the gap between the 21st century and the pet industry. So with the dog monitoring activity system, we're going to be applying the knowledge that we've learned throughout the coursework here at UTA. We're going to be dealing with microprocessors, programming, circuit and motor design, as well as wireless transmission. And last but not least, product development. Entrepreneurship is a huge thing nowadays. A lot of students are overwhelmingly showing a lot of interest in the subject, and this will pretty much give an insight as to how to go about creating a product.
The dog monitoring system will consist of 4 subsystems. These 4 subsystems are the tag, the dog door, the main control unit, and the website. First, we're going to be talking about the tag. The tag will be fitted onto the dog's collar. It's going to be a structure that holds all the components and it will be durable and waterproof. The reason for this is if the owner is playing with their dog roughly, or if they're playing catch and the object goes in the water and the dog tries to go for it, the tag will withstand all these conditions. The tag will also gather the activity of the dog and will gain access to the dog door. The activity will be gathered every hour, and it will be connected to the main control unit wirelessly via Bluetooth. Whenever the dog is within 3 feet of the dog door, the RFID chip that will be in the tag will connect with the dog door, and it will unlock the dog door for them to get in. Next, we'll talk about the dog door. As you said, the dog door will be going with RFID communications. When the dog is within 3 feet, like I said before, the door will unlock. This is so whenever the dog can go in and it won't be a problem. If the dog is within 3 feet of the door and is just standing still, the timeout system will happen. This will be only 5 seconds. So if the dog is standing still by the door, it will have 5 seconds to start moving before it locks again, or after 5 seconds and it's still standing there, the door will lock again. Once the dog will start moving, the door will unlock and the dog can go in. The third subsystem is the main control unit. The main control unit is where everything is processed. So once the dog's activity every hour comes from the tag goes to the main control unit, it is processed there, and all that data activity will go to the website, which will be talked about later on. Also, whenever the door is open, the antenna that's going to be in the door will go through to the main control unit, and that will also be processed to go to the website. The main control unit will have both a Bluetooth and Wi-Fi module. The Bluetooth module will be connected to the tag, and the Wi-Fi one will be connected to the website. The next will be the website. The website will hold all the activity. Once the tag transfers the dog's activity to the main control unit and is processed and it hits the website, it will show up on a connected line graph every hour. It will also show how many times the dog door has been opened. The website will also give the user control to restrict the access of the dog door. As in, if they don't want if they don't want the dog to be going out anytime soon, they can just restrict the dog door to be open for this amount of time, and the door won't come open until time has ended. And also, the website will also give the user control to see the activity immediately. So if they don't want to wait an hour for it to reload and show the connected graph of the activity, they can just say, show me activity now, and it'll show the activity that has been going on since then from now, and won't wait for the next hour.
All right, so I'll be telling you about the learning plan. The learning plan has three major aspects: the technical and physical requirements, current knowledge and expertise, the timeline, and personal responsibilities. So, the technical and physical requirements will consist of the microcontroller, Bluetooth, the motor, battery and power supplies, the accelerometer, and testing equipment. These are going to be very important when it comes to getting this project done timely and efficiently. The next part, the current knowledge and expertise, is going to deal more with what we're good at already and what we need to learn more of. So, myself and David, we're both very good with circuit design and actual hardware. Stephanie and Deej are very good with C and Java and other programming aspects. We're all very good at microprocessors, which is very important as we're all very, need to know how these things are all going to communicate with each other. So we're going to split into two groups. You have the hardware and the software group. The hardware group, consisting of myself and David, will be the motor and accelerometer when it comes to any kind of actual research. Then you have the software, which is going to be Deej and Stephanie. And that's going to be the Bluetooth and the microcontroller and data transmission research. We're going to need to adapt to the setbacks and act proactively if anything does come up when it comes to the actual getting this thing done in a timely manner. Now, the timeline of personal responsibilities, myself, I will be needing to do the motors and accelerometers. Deej will be doing the test equipment and programming. David will be doing most of his research in different power supplies and batteries. And then Stephanie will be researching microcontrollers and Bluetooth technology. This is all laid out pretty regularly in this plan here. You can kind of see the pairings between the software and the hardware groups. One major thing is we will all be doing research into, like I said, getting through setbacks if they do occur, so we can get this done in a timely manner. And this is spread out through April all the way through November as well.
Please tell me. I'm going to talk about the design description, which will include the block diagram, the design options, and the design choices we made. This is a block diagram, which is broken up into three different parts: the dog collar tag, the main control unit, and the dog door. These devices will all communicate through various means using Bluetooth, Wi-Fi, and RFID. The design options we were considering for the dog door were to make it fully off or mechanical, where the door itself will be hydraulic and open and close as needed. The other method we chose was just using a simple locking mechanism to allow the dog to push open the door, and it would swing closed on its own. The other option we were considering was combining the dog door and the main control unit. The problem with combining both of them would be the power supply. Would it be large enough to handle both of them for extended periods of time? The other option is to separate the main control unit and the dog door. This would allow us to solve the power problem by plugging the main control unit directly into the wall. Our design choices, what we are going to use is the MQ MC3430, which is a accelerometer which will be able to have a three-axis system, so we'll be able to tell any direction the dog will be moving. We'll also be using TICC2540, which is a combination microcontroller and Bluetooth module, which will make it more convenient than having two different units. We also use Liard's BL620, which is a Bluetooth module with a 1 megabyte transfer rate and has an internal antenna. And the last one is TICC3100 mod, which is a Wi-Fi module with up to a 16 megabyte transfer rate. The solenoid lock, we haven't decided on which one we're going to use now because we're not sure on the size of the dog door and how much force it's going to be able to need to hold to stop anything from coming in.
So For our task analysis and teamwork plan, as stated before, there are two main parts, the hardware and the software. So in the hardware, there's the locking mechanism, the battery power, Bluetooth, microcontroller, fabrications, accelerometer, and the implementation of the hardware. For the software, we have the microcontroller specifics, the website and app development platform, the programming languages that are involved with it, and lastly, actually implementing the software into the hardware. We will be having weekly meetings, and we're going to structure it in a way where we first will talk about old business, which is going to be what we've dealt with in our last meeting. Next will be current business. We'll be talking about what we're currently working on, the projects involved with that. New business is what our goals are for the next meeting and what we want to have achieved by then. And lastly is the overall progress to see, right where we are on track with our timeline. Also, in addition to our weekly meetings, we will have monthly meetings with our sponsor. Dr. Turner will be meeting with us one day out of the month, and we're going to be figuring out how to incorporate his ideas into our design. So each of us will need to have a specific position to help progress the project further and further. I'll be taking the role of the Director of Communication, which will be dealing with making sure each group member is connected with what the other group member is doing. Director of New Business will be running meetings and mainly focusing on the next thing. Not the current thing, but what's next with each person. The Director of Resources, which will be dealing with the available resources, people we can talk to, professors we can talk to, websites, any specifics on basically anything that we need to know. And our secretary will be taking notes in meetings and providing all the documents and logs of everything that's going to happen. So with me being Director of Communication, Matt Ponto will be assigned to Director of New Business, Director of Resources will be assigned to David Seekins, and Stephanie will be our Secretary. So in our chart, we can kind of see how this project's going to be broken down. Right here, with the dots, are the main deadlines that we're going to have for each specific section. We have the dog collar tag, we have the main control unit, we have the dog door, the wireless module, software, and then the final product. We expect our final product to be done somewhere around November, and we expect our final project report and final video to be done early December.